Hey Terry, I just wanted to kind of walk you through what you're going to be doing on my second and fourth period for FPC. First thing I had the students do today for fifth and eighth, or sixth and eighth, sorry, is I had them come in and write their learning target. It helps if you stand at the front of the class and kind of hold the notebook and stuff. Usually that reminds them what they're doing. So I had them write the learning target. And then separately, once everybody was kind of settled in, I would take this time to maybe go over your class expectations. And then I would hand out this worksheet. This is going to teach the kids first where protons, neutrons, and electrons are located, what their mass is, their charge, and how they're arranged in the atom. The second part tells them how they can figure out how many protons, neutrons, and electrons are in the atom just based on looking at the periodic tiles. So hand this out, have them fold it in half, do the whole lick and tear sort of thing, and it should go into the notebook like this. Okay. What I had them do after they tore it is I highlighted these boxes and told them that they needed to fill out, to the best of their ability, the green boxes. This is usually a great way to get the kids to not go on ahead and not get freaked out because they don't know the other stuff. If they've been doing their homework, this stuff should be pretty easy. Second period, horrible about doing homework. So you're probably going to have to walk them through that. They should be able to tell you that protons are in the nucleus along with neutrons, and that each of them, both of them are in the nucleus, and the electrons are out in the rings or the orbitals. They should also know that protons are positive and electrons are negative. They may not know that neutrons are neutral. Okay. I then went through and told them about the atomic mass unit, how it's sort of a new unit, and how it's like, a millionth of a gram, so it doesn't really make sense to use those sort of numbers and instead just give it a new unit. So 1 atomic mass unit for protons, 1 for neutrons, and even though electrons do technically weigh something, we're just going to say 0. Okay, at this point, I told the kids that the nucleus was the center of the atom, and if that's where the protons and neutrons were, how in the devil do we figure out the mass? And I kind of posed that as a challenge question, gave them a little bit of time to do it, and most of the kids were actually able to come up with protons plus neutrons. Most of the kids were also able to tell me it was positive when I asked them, hey, what would that be? If you've got protons plus, or positive plus neutral, what's the overall charge going to be? Most of the kids said positive, and I kind of liken that to 8 plus 0 or 20 plus 0 or 1,000 plus 0 is always going to be the number and not the 0. And the energy levels, perimeter is kind of a geometry word, but outskirts of the atom, no mass, negative charge since it's mostly electrons. This is where things get a little more technical. I had the kids fill in the nucleus, and I really highlighted protons and neutrons. And then from here, I really tried to emphasize the idea of like a cup filling up. You can't fill up the second cup till you filled up the first. So you fill up the first, it can take up to 2 electrons. Both of those electrons have to be there before you can fill up the next one. 8 have to be in there, then you fill up the next one. So kind of remembering this 2-8-8 rule. And then I gave them an example. You can give them any example you want. For a second period, you might want to give them something simple like carbon. For fourth period is pretty sharp, so you might want to give them something more like magnesium, and walk them through that. I would like you, this is really important to me, if you could walk them through where to put the dots. For ones that are not paired, like these ones, put them on opposite sides because they repel. And then what I do is I have them start at the top and go clockwise and go dot, 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 dot. Then they start pairing, dot, 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 dot. And that makes it easier down the road to count and keep track of. So if you could kind of teach the kids this same sort of technique, I would really, really, really appreciate it. I can always pick that up later and reteach it to the kids, but it'd be helpful if I don't have to undo something else. So there's that. This actually took about half an hour to get through. So at this point, I gave the kids about a 2-minute move and wiggle time, and then we kind of came back. I kind of did an overview of what we'd learned. Now you guys know where these particles are, how much they weigh, what their charge is, and how they're arranged. Now we're going to move on to the next one. And so I kind of went over that atomic number equaling the number of protons. Since protons are positive and the electrons are negative, you need that balance in the nucleus to keep it stable. So if you know the atomic number, you know both of these. This is the atomic symbol, atomic name or element name, and the atomic mass, which is the number of protons and neutrons. Go back to this, nucleus, center, positive, or protons plus neutrons. Protons plus neutrons. So this is the mass of the nucleus. This is kind of redundant, you can scribble that out. And then I did one on their own. We kind of did this together. This is a great place to see where kids are stumbling. So I gave them this, I set it up, and then I let them fill in the numbers. And so protons was easy, electrons was easy, but what do we do for this? Round. Round up if it's closer to the whole number, round down, and when in doubt, round down. So this one's really close to 40, so you round it to 40. 40 minus 18 equals 22. Blam. From here, they should be able to get started on the homework. The answers to these are the same sort of thing we just wrote here. They're literally writing the same thing over. So really try and make it clear that, this is supposed to be atomic number, symbol, name, mass. And then this is where I always trick kids. Give them a couple minutes to do this, and you'll always get them going through it way too fast. Atomic number equals the number of protons or electrons. Atomic mass equals the number of protons plus neutrons. Really highlight this point. Release the kids, and this is where doing the highlighter might be helpful. Sorry, I should have gotten this before. You might want to highlight these and kind of let them loose and then review. That's what I did with my 6th period, and it worked out really well. I told them they had to get through all the green before they could go on, and they had to check with me. Otherwise, you can kind of sit and watch them and then check in later. This is where you can catch a lot of kids going off. For some reason, I've been getting a lot of kids saying the number of neutrons is 0. I'm not sure why. But anyway, there's that. And then basically kind of let them loose. Now to do this, I forgot to say, you're going to have to give them the periodic table, which is over here. Okay. Please, this is very important, please have them fold this in half, put their name on it, and tell them to put it on the back cover of the notebook. And tell them I'm only giving them one copy, so they better put their name on it and try and remember to put it in. But worst case scenario, they leave it behind, and I can give it back to them. So, in review, basically you're just walking them through this page and this page so that they can do this page. And for my, for my 6th and 8th, this is due Tuesday, and for my 2nd and 4th, this is due Wednesday. It shouldn't take them too much time to do this. Most of the kids that are really sharp finish by the end of the period, given 20 minutes. So I was pretty impressed. Anyway, that is Tuesday's lesson, or Monday's lesson. All right.